Hey gang, today we're going to be looking at scatterplots and lines of best fit. In science and other areas, we often want to determine if there is a relationship, linear or otherwise, between two variables that we measure. To initially see the relationship, we plot pairs of measurements on what is known as a scatterplot. So looking to see if the relationship is linear or nonlinear is looked at by plotting the coordinates on a coordinate plane and seeing if there's a trend in the data that follows a linear pattern or a nonlinear pattern. So here's our example. Students in Mr. Rivera's math class wanted to see if there was an association between the number of siblings a student has and the number of first cousins she or he has. They asked 12 of the students in class and found the following. So we have a list of data points that we need to plot. So part A is just to create the scatter plot of the data on the coordinate plane. So we go ahead and use those points as if they're coordinates, siblings being the x, cousins being the y, siblings being the input, and cousins being the output. So we have siblings x 2, cousins y 5 as our first data point. So we plot 2, 5, which is right 2 and up 5. 6, 10, which is right 6 and up 10. 3, 8, which is right 3 and up 8. 2, 7, which is right 2 and up 7. 5, 11, which is right 5 and up 11. 3, 7, right 3, up 7. 4, 8, right 4, up 8. 7, 14, right 7, up 14. 3, 5, which is right 3 and up 5. 1, 4, right 1, up 4. 6, 2, right 6, up 2. And 1, 3, right 1, up 3. Now, looking at this, we know right away that this is definitely not a function on its own. It's not a function because there are multiple inputs with numerous outputs. So we see that the input of 1 has 2 outputs, the input of 2 has 2 outputs, the input of 3 has 3 outputs, the input of 6 has 2 outputs. So it's not a function, but we could maybe use a function to model it or to show the trend, which is what we're going to get into. Okay, so now that that's done, we're going to use it to answer some questions. Okay, so here I have all those same points already plotted. So we want to answer the question, does the number of cousins tend to increase as the number of siblings increase? And by looking at this, we see that there is an upward trend. As number of siblings increases, number of cousins also increases. If we look here, with one sibling, it looks like you have 2 or 3 or 4 cousins. But with 3 siblings, it looks like you have 5, 7, or 8 cousins. And with 5 siblings, it looks like you have 11 cousins. So as the number of siblings increases, so does the number of cousins. So we can write, yes, because as siblings increase, so do cousins according to our graph, which shows an upward trend. Part C, do any of the data points on the coordinate plane appear to be outliers, meaning they are far away from the rest of the data? Explain. So there is one point that's pretty far away from the rest of the data. So this point right here does not follow the trend. So we can say the point 6.2 is an outlier because it does not follow or doesn't follow the trend of the other data points. Okay, so far we've learned two very important words for math in this lesson. We've learned scatterplot, which is a graph that scatters different points on a coordinate plane to look for a relationship, an outlier, which is a point in a scatter plot that doesn't follow the trend of the data. It's far away from the other points. All right, so let's continue. Part D, ignoring the outlier from C, use your ruler to draw a line of best fit through the data. So now another really important term is line of best fit. And a line of best fit is a straight line or a curved line that follows the trend of the data. It doesn't connect all of the points, it just follows the trend. So here I could draw a line straight through these points that seems to follow the pattern. Right? So it looks like I've got equal amounts of points above and below that line, excluding the outlier. That one is much further away. So then part E, is the slope of the line of the best fit line positive or negative? And how does this relate to your answer in part B? It is definitely positive because it's increasing from left to right. So we're going to say it is positive because it increases from left to right. And indicates that as siblings increase, cousins increase as well. Right? So that positive slope tells us that there's a positive trend in the data. It confirms that as the number of siblings increase, the number of cousins also increase. All right, let's continue with this. So now I have the same graph with the line of best fit drawn in already. Part F, to the nearest whole number, what does the y-intercept appear to be? And what does this tell us about the siblings and cousins? So our y-intercept, again, is the point where we cross the y-axis right here. And in this case, it's 3. So what does that mean about siblings and cousins? So since the y-intercept is 3, or, not or, we can assume that someone without any siblings might have, because we're making a prediction, 3 cousins. And that makes sense because that point there is 0, 3. 0 matching with number of siblings and 3 matching with number of cousins. So we relate that back to the y-intercept, being that somebody without any siblings has 3 cousins. Okay, so hopefully now you understand the basics of a scatter plot, and you can use that to answer some questions on your own. So in the example, there was a positive association or correlation between the two variables because as one of them increased, so did the other in general. We can also have negative associations, which occur when one variable decreases as the other increases. Try the remainder of today's lesson on your own. So go ahead and continue. Check in with me so I can make sure you're getting them right before moving on to today's exit ticket.